All right, Pre-Cal 10. So here's our next video on graphing linear and nonlinear equations. Now, we've graphed linear equations before in grade 9. Here we're going to look at them again because graphing does become a very regular part of Pre-Cal 11, Pre-Cal 12, foundations, even workplaces, because being able to graph relationships between things is helpful. You like visuals. Linear means straight lines. Nonlinear means not straight lines. We're going to look at both. So, to start, there's always, what's the difference between an expression versus an equation? So here you'll get vocab, but also this is the type of stuff we've seen before. It's like you'd get a question like this, and it would just say simplify. This is what we call an expression, because all you can do is to group these things together as best you can and get to there. You have to stop because you can only simplify. You can solve once you have an equation. So if we had this exact same expression, but we added an equals sign and any number, even if it's 0, now you can solve because you have an equation that is balanced and you can solve for the unknown information. If you don't have an equal sign, you have an expression. It is the equal sign that makes it an equation. So now we have 7x minus 7 equals 0, and now it's add 7 to both sides. Divide both sides by 7, x equals 1. So you can actually solve now. Here we can't solve for anything because we don't have it equal to anything. We're not given that information. That is the defining difference between an expression and an equation. So just so you're not confused, when you see simplify, it's because you're not solving for anything. You're just simplifying an expression. All right. Now, graphing. Slope-Intercept Form. Y equals mx plus b. This was hammered home in grade 9, but b is your y-intercept, which is where your line goes through the y-axis, and it stares you in the face in this equation. It is a 4. So we know that it's going to go through at plus 4. Point exists right there. M in any slope-intercept equation is your slope, which means rise over run. Now here, ours is negative, and it's important to consider that it either means negative 2 over 3 or it means 2 over negative 3. And you'll see that the difference doesn't matter. Remember, we can count out our slope. This is my rise or change in height. This is my run or change in length from point to point. So let's look at this one first. My rise is positive, so I would count up in a positive direction, 1, 2, and then I would count negative x direction, 1, 2, 3. And my next point would exist right there. If I used this one instead, then I would count down 2, but to the right 3. In the end, I end up in the same pattern for my slope, and then I would connect my points together, and that would be that, right? Now you're going to use a ruler. I don't have one handy. And you would connect your points. So you can map out your slope and just plot your y-intercept. Y-intercept, slope-intercept form is great for that because the information is staring you in the face. Y-intercept right here, plot me, and then map the slope, staring you right in the face. So we'll do a bunch of that practice. Here's another one. What's my slope? Again, negative 3 over 4, and then y-intercept of plus 1. So where do I go through the y-axis? At 1. And then I'm down 3, 1, 2, 3, and then over 1, 2, 3, 4. Or I'm 1, 2, 3, and then negative 1, 2, 3, 4. Either way you want to look at it, there is your line. So slope-intercept form is great because the slope is staring at us. We can just map it, and we have the y-intercept. So standard form is a little bit more cumbersome because we don't have that information. But we do have a nice detail, right? Anytime you are the y-intercept, so any point that exists on the y-axis has the same x-coordinate. It's 0. 0x coordinate for all of those, right? So it means when x is 0, we get our y-intercept. And then obviously when y is 0, we are going through the x-axis. So this equation can give you your intercepts nice and quick, right? Because if you look here, your input, remember that input-output from the previous video, we're inputting for x here. So in this case, we're saying when x is 0, what's y? So, well, when x is 0, this is 0, because 3 times 0 is 0. So you just have 2y equals 6, y equals 3. So when x is 0, y is 3. You get a point on your graph right there. And then this one says, okay, what about when y is 0? So well, now we have 3x plus 0 equals 6, because 2 times 0 is 0. And then you have 3x equals 6, so x equals 2. So you get both your intercepts. Now, it's always good to check at least one more point to make sure you didn't screw anything up. And there should be a symmetry to your graph. If you look at the difference between my x values was 2. So to keep symmetry, go 2 more. And you could go to 4, but you could also go the other way from 0, and you could pick -2. Either way, those points will generally give you nice, perfectly intersected points because of how we set up these questions. But you also see what happens here. What we're doing here is we're doing some substitution now. We're saying when x is 4, what is y? That's what I need to know. So you sub in. When x is 4, what's y? Well, algebra, 12 plus 2y equals 6. Minus 12 from both sides. 2y equals -6. Divide both sides by 2. Y equals -3. So you can see that as your x continues to increase, your y continues to decrease at the same rate we would expect. So you get, where are we? You get -3. So, and then you do the same for -2. You can only imagine where you'll end up here. It's always good to check 3 points to make sure you are graphing the line correctly. So always start with your intercepts. Now, like you can right away in your table, just go, okay, well, I'm going to put a 0 here and a 0 here, and I'll go from there. Now, if you have fractions in the equation, it's not technically standard form, but it's close enough. But let's get rid of the fractions by multiplying everything by the lowest common multiple. This was an algebra that we learned in grade 9 as well, but here it is again. So 15 divided by 3 is 5 times 2, so we have 10x minus 6y equals 30. So exact same equation, I just no longer have fractions, so life's a bit easier. Now, when x is 0, I have -6y equals 30, because this becomes 0, right? So I'm taking a couple liberties here. I hope that you can see that. And then divide both sides by -6. Y equals -5. So we have 1 point. And now when y is 0, we'll go from here. We just end up with 10x equals 30. So x equals 3. Again, I'm taking some liberties on the algebra, but I think that you're probably all comfortable at this point. And now, good practice. Let's just take this number, but opposite sign. Or you could just increase it 3 more to go to 6. But let's do this one instead this time. So we'll say, okay, well, what about when x is -3? Well, all right then. 10 times -3 minus 6y should be 30. -30 minus 6y equals 30. -6y equals 60. Add 30 to both sides, and then divide both sides by -6. Y equals -10. So we can plot these 3 points now. 0, -5. 3, 0. -3, -10. And sure enough, there's my lovely, lovely line. So standard form takes a little bit more, but you do get your intercepts out of it, which is going to come in handy in sections to come. So now what about nonlinear equations? Well, nonlinear equations are graphs that are not straight lines. So you need to just try a variety of points. You can't just plug only positive numbers in. You need to check negative numbers. And you can be a little bit strategic. Here my y is squared. So instead of picking values for x, I'm going to pick values for y and see what happens to x. And I'm going to go both positive and negative realms of the spectrum. So I have 1, 2, 3, 4, 5, 6, 7 spots to choose from. So I'll put 0 here. And what I'll do is I'll go 1, 2, 3, but I'll go -1, -2, -3, just to try both positive and negative world. So the important thing here is it's squared, and it's the entire input squared. So if y is -3, it looks like this, in brackets, -3 squared. So -3 times -3 is 9. Well, what about when y is -2? Well, -2 times -2 is 4. -1 times -1 is 1. 0 is 0. So you can see I have some interesting symmetry here. I'm not going to show all those because this is a pretty straightforward equation. But now we can plug this. So when x is 9, y is -3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, -3. But when x is 9, y is also +3. So we actually have a point up here as well. So you can already tell this is not going to be a function because it wouldn't pass the vertical line test. When x is 4, y is both +2 and -2. When x is 1, y is both +1 and -1, and then 0. So we've seen this shape before. It's a sideways parabola, but we are graphing a graph that looks like this. So it's important you try both positive and negative values. Otherwise, you won't get this shape. So try both. This is going to be all about just plotting, picking values and subbing in. That's how we're going to do it this year. We'll learn other ways years ahead. So now this one. Okay, so the x squared, y equals x squared minus 4. So I'm going to pick again. I'm going to go, okay, well, how about I'll do 0. And yeah, sure, I'll do 1, 2, 3. And I'll do -1, -2, -3. So when x is -3, I get 9 minus 4, which is 5. When x is +3, I'll get the same thing. When x is -2, I'll have 4 minus 4, which is 0. So 0, 0. When x is 1 or -1, I will have 1 minus 4, which is -3. So all I'm doing is subbing my x value in for the x squared, right? 3 squared is 9, 2 squared is 4, 1 squared is 1. And then when x is 0, I will have -4. So now we can plot this thing. When x is 0, y is -4. And then when x is 1, we're at -3 and -3. And then 2, 0, -2, 0. And you can see we have symmetry here as well. We'll talk more about that as we move into graphing. But we have this time what's called a parabola. Boom. So again, you got to try the positive and negative realms of the variable that is being squared. The last one was the y, so we picked it on the y. Now, here we have 2. So I'll tell you straight up, this is going to be a circle. This can be hard to come up with because you don't have one of the variables simplified. So a good way to maybe approach this is to change the equation, subtract x squared from both sides, and then square root both sides. That'll give you this. And now what you can do is you can just plug in values for x and solve for y. It'll show you where you're at. The thing to remember here, though, is this negative is independent of the exponent. So it makes that negative. And then there's going to be some boundaries here because you're not allowed to have a negative underneath the radical sign. So x squared, so when x is 3, x squared will be 9. And that negative means you'll have -9. So that means x can't be anything bigger than 4. And it can't be anything less than -4. This is one of those domain pieces here because you're not allowed to have a negative number under a radical. Not allowed. So what we have is we have some boundaries on x. X is going to be in between -3 and +3. So let's plug those values in then. And then let's plug in values in between. 2, 1, 0, 1, 2. Now sometimes it helps to be strategic when you have a radical, but and this should be plus or minus because we're going to get 2 values when you square root. We'll talk more about this one in class, and I'll do an independent video for circles later. Don't stress too much about this. It's a little beyond the grade 10 spectrum, but let's look at it anyways. So when -3 is squared, inside you'll have 9, but then -9. So you get a 0 here, and you get a 0 here. So what you get is you get, when x is -3 and +3, y is 0. Now, what about when x is 2? Well, 2 squared is 4, so you get this is why strategy helps sometimes. Get the square root of 5, and then we'll get the square root of, When x is 1, we'll have the square root of 8, so not perfect numbers. Just look when x is 0, though. When x is 0, you get 9, which means the square root of 9 is 3, so you get plus or minus 3, because we have plus or minus in front of the radical. So when x is 0, we get plus or minus 3. And all these other answers on the bottom here will be plus or minus, plus or minus, plus or minus. And you can estimate these, but once you're here, this is root 5, this is root 8, this is root 8, and this is root 5. But the big one is the plus or minus 3 for the y, because we have here and here. So you can, this is going to be a circle. We'll talk more about circles, maybe grade 12. Don't want you necessarily to stress yourself out with this example. Look at it in the notes. It's nicely laid out in the notes, but it's all about substituting values in for x. And in this case, what is x not allowed to be? Because we have it under a radical. This is an exponential. So this is definitely not a linear equation. This is a great example of a type of equation that demonstrates exponential growth. And also, you got to remember your relationship of positive and negative exponents. Because remember that 2 to the negative 1 is 1 over 2 to the positive 1. So if you have 2 to the negative 2, we're going to have 1 over 2 to the positive 2. And since x is in my exponent, let's pick some negative values. So negative 3, negative 2, negative 1, 0. And then let's go 2, 4, 8, just to see what happens. So when x is negative 3, you have a negative 3 exponent, which means you have 2 to the negative 3, which means you have 1 over 2 to the 3, which is 1 over 8. So it's a small number. If x is negative 2, you have 2 to the negative 2, which becomes 1 over 2 to the 2, which is 1 over 4. So, and then you'll have 1 over 2. And then when x is 0, you get 1. So what you get here is you get a graph where, as we go into the negative realm, we get closer and closer and closer to 0, but we will never actually hit 0. We'll get infinitely close to 0, and that's what we call a horizontal asymptote. We'll talk about that in a future video. And then what happens is we go away. Well, when x is 2, that's too dark. When x is 2, 2 squared is 4. When x is 4, well, 2 to the 4 is 16. When x is 8, well, 2 to the 8 is a pretty large number. But what you can tell is this graph just takes off. It goes up, 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 up. That is what we call an exponential graph. Again, the whole idea of this section is to introduce you to nonlinear equations, not really to wrap your head around them fully, but just be able to plot and graph something that is not a straight line. I think we got one more here, 1 over x. This is interesting because there's more here that we'll learn about later. What are you not allowed to have for x here? X is not allowed to be 0 because we can't divide by 0. So we get what's called a vertical asymptote through that point. Again, we'll talk asymptotes later, definitely pre-cal 11, but it's a line that your graph is not allowed to touch. It'll get infinitely close to it, so it's not allowed to touch. So what we have to look at is, well, what happens as I approach 0 from the left and 0 from the right? So, when x is negative 2, negative 1, and then like you can say 0 with a negative means from the left, so from the negative, and then 0 plus means from the right, and then we'll say 1, 2, and we'll just stop there. So when x is negative 2, you get negative a half. When x is negative 1, you get negative 1. So we have a point here, we have a point here. Now, if x would be closer, it gets closer and closer to 0, we can take, well, what happens when x is negative, what happens when x is negative 0.5 or negative a half? You have 1 over negative 1 half, which means you have 1 times, flip and multiply, 2. So you get to negative 2. So the behavior of your graph is this graph is going down. So it's going to go like this and shoot down and get infinitely close, but never going to actually touch. And this is going to get infinitely close to 0, and it's also never going to touch because you can't divide 1 by anything to get 0, right? Not possible. So now we just got to check what happens from the other side. Well, from the other side, when x is 1, we get 1. When x is 2, we get a half. So it's the same behavior, just in the positive realm. If x is a half this time, we'll put it here, if x is a half, 1 over 1 half is the same as 1 times 2, so 2. So when x is a half, we're at 2. So this one is looking like this. So it's going to go up and then scoop down and shoot down. So they're basically mirror images of one another. This is a nonlinear equation. This is what we call a rational equation. We talk about it in grade 11, but this is just a very brief example and introduction to it. I don't want you to worry about asymptotes and all of the vocab we covered here. I just want you to be able to plot points and determine general behaviors of a nonlinear equation. A lot of notes here, sort of nicely covered in the notes here, section 2.2. So make sure you're supplementing the video with the notes. But great work, keep it up. I know this one can be frustrating, so try it a few times and just grab some graph paper and practice. Awesome. See you next time.